Hello everyone, this is Yusuf Danijo speaking for the Balancer team. So we set out to solve the problem of the predictability of the apparent power generated by wind turbines on a wind farm. We started to also use the wind direction, wind speed, and some other variables that have to do with power generation on the wind farm. In order to solve these problems, we decided to use Balancer PG, which is a Postgres service, and also the UAA, which is also the UAA service on Predix in order to secure our app, and the PG, which is Postgres in order to persist any data that we need. And then we also created three apps mainly, which two of them are the functional ones. The Balancer ML, which basically hosts our machine learning algorithm. So in order to visit the Balancer ML machine learning algorithm app, you can go to HTTPS of this, and then right there you find different form of analytics depending on what exactly you're looking for. This one applying to the whole of the dataset, and this for one turbine. So this is for prediction for a turbine. That's turbine 1. This is for turbine 2. If you enter a turbine that does not exist, say turbine 11, it tells you that the turbine does not exist. And also on the other side, there is the front end part of it, where you can find the analytics that was brought from the machine learning app itself. So you can get that on this. Then you have the result for each of the turbine. So whenever you see a scenario where you have a negative situation, which means the power that was being expected was far higher than the actual power that was got. And the case study shows that there is not much difference between the power that was derived at the end of the day and the power that was expected. So we also note that this app is well secured, so people don't go in anyhow. So this was made possible using the UAA. So what this gives us is that owners of wind farms will be able to know exactly what they can expect for a period of time regarding their wind farm, so there can be reasonable level of forecasting regarding power generation on their wind turbine.
Hello, my name is Alex, one of the team member for the Balancer app. I'm just going to show you a quick overview or give a quick overview of our codes and how our app is functioning, and then give a brief explanation on the business benefit of our app. The main function of our app is actually to predict the apparent power of a wind turbine, given these various features over here: the ambient temperature, the hydraulic oil, the phase currents, the phase voltages, the wind direction, the wind speed, and then the turbine status. Over here we have this is the main function actually, which just calls on all these other function over here to carry out the training of the algorithm, validation, and then testing. Over here we have a function for the apparent power, which is used to calculate the apparent power given the active and reactive power of the wind turbine. The polynomial feature is used to actually map our data set into a polynomial function, because we are using linear regression for prediction. The feature normalize is used to scale our data set why the linear rate cost function is used to compute our cost function. The training lane reg is used for the training of our algorithm. So using this particular function over here, and then the learning curve is to ensure that our algorithm is actually working properly by showing the slope, bias, and variance. I'll go back to the main function and then just give a quick overview. Like I stated before, the apparent power is computed with the reactive and active power of the wind turbine. We actually divided our data set into three categories. We have the trained data set, we have the test data set, and then the validation data set. This is actually to ensure accuracy. Our algorithm is trained using some numbers of our data set, and then we validate to ensure that it's actually working properly, and then we now use new data set to test it so as to ensure accuracy. Down here we actually calculating the percentage error based on our prediction, and then the actual value of the apparent power to actually show how our algorithm is working well. Now go back to the command window where we can see the results of our algorithm. Okay, over here we have the result of our algorithm. The number of tested data sets was 11,327. That's gave us percentage error less than the number of data set percentage error less than or equals to 5% was 10,837, which is actually large. Then those with error greater than 5% were 490 out of the tested data set. Then we also had over here the number of tested data set percentage error less than or equals to 10% was 11,073, while the data set percentage greater than 10% was 254. This actually shows that our algorithm is working properly, and then the prediction is very accurate with this percentage error that we have over here. This algorithm, our app actually have a very huge impact on businesses. Constructing a wind turbine farm is quite expensive, and as such, a proper survey actually have to be done to collect data on the location that you want to install your wind turbine on to ensure that that was the best environment. With the collected data set, our app can be used to actually test how your data set works by ensuring that you getting the major power that you need from that wind turbine. So you can use that to test the survey data that you've collected, and this can also actually save a huge cost because it can give you let you know the apparent power that you need.